I'm going to start today with a little recap, okay, of what I did the other day, which is the black hole, singularity especially, okay. What is this singularity thing? We found out it's a little bit scary stuff. That's what it is. Okay, so this is what I showed the other day. Give me a second here. Let me put it in motion. There it is. This is the astronaut falling into a black hole, and he gets stretched all the way to the singularity, okay. And this is what they illustrate. And yeah, this is what they say is happening with anything that falls into a black hole. Once it crosses the event horizon, it gets stretched all the way to the singularity. And that's kind of weird because not only because it's weird in itself, but it's weird because the majority of mathematicians out there say something totally different. They say that as soon as you pass the event horizon, you get crushed out of existence at the singularity. You go zip into the singularity and get crushed out of existence. Every atom in your body gets crushed out of existence. It gets turned into empty space. No size, no shape, no nothing. Okay? That's the official version. And here it is. Don't believe me. Here are the experts, okay? Has one fellow there, Cole Miller, University of Maryland, crushed out of existence. And you see others there, they say exactly the same thing. All atoms, every piece of matter is crushed out of existence. Okay? So that's, I would say that's the majority view, or that's the off the cuff, statement that they'll give you. They say everything gets crushed out of existence in a black hole because it goes through the event horizon immediately at the speed of light, obviously, gets sucked into the singularity and gets crushed out of existence. Its shape, everything goes away. Okay, so that's their version, but here you have another fellow I talked about the other day. His name is Derek Miller, and he says the following: he and his rocket ship do not disappear. Talking about an astronaut, right? Penetrating the event horizon. Instead, they seem to stop frozen in time. So once you cross the event horizon, you do not disappear or fall instantly into the singularity. No, you get frozen in time. You're suspended in time, so to speak. And he says, but if you could see that light, you would see everything that has ever fallen into the black hole, frozen on its horizon, including the star that formed it. Okay, so he's saying what? He's saying that all objects that fall in through the event horizon are still there. Okay, the only problem is you can't see them. It's a question of observer on the outside not being able to see what's inside. But they have not disappeared. They have not been crushed out of existence, according to this fellow, this expert. Okay, so we have a little difference of opinion. Looks like the math leads to different conclusions. These fellows say, hey, the mass is so great, the gravity is so great, it's going to crush any bit of matter out of existence. This fellow says, no, you're suspended in time. It's just the outside viewer, the observer, he cannot see you because you're not emitting light. The object that fell is not emitting light towards the observer, far away, distant observer. That's the issue, okay? So we have a difference there. Either it gets crushed out of existence or it's still there, you just can't see it. Those are two different things, okay? And in fact, Derek goes further and he says, you could find yourself in a white hole, which would push you out into a whole other universe. That little point there where they cross singularity, that is an Einstein-Rosen bridge, right? And then what it is just a little line, they say a one-dimensional line that connects these two universes, okay? It's a bridge that is long. It connects the space of both universes. If you go beyond it, you end up in the parallel universe. So that is how we could what? Use a black hole to travel from one universe to another. Okay, we have a little bit of a problem here as well, because what this fellow is saying is that not only you get stretched, from event horizon all the way to singularity. I mean, you can imagine a poor astronaut, he gets stretch, and somehow he survives that stretching, goes right through the zero-dimensional singularity, through the one-dimensional Rosen bridge, and come out of another universe. So the astronaut doesn't die. He says there's a possibility he survives and goes to another universe. Now that is weird because now I'd like to stretch you on the rack. Forget about being stretched from the event horizon all the way to singularity. I'll stretch you on the rack, and once the doctors fix you up a little, see if you can travel anywhere. But he says you survived the trip, and in fact, here you have one boson. He's a boson. And his name is Brian Greene, and he travels through a wormhole, and he goes to see himself, I guess in another universe, but he says he goes to see himself in the morning. So that's him traveling late at night and finds himself with his own self in the morning. Okay, so I guess you can travel to another universe or stay here on Earth. You'll just be, traveling to see yourself early in the morning. And this is what these people put out there as science. Right? This is science. It's really quite scary when science gets like this, because if they show me and they say this is a cartoon or this is just to have fun or laugh a little, no problem. But when they put this out as science and they say this has been proven mathematically, well, then we have a little bit of a problem with that. Okay. And here's a lady, I showed her last week, okay? And let's see if I can get this up here. And her name is Jana, and Jana Levin, and this is what she's going to be doing. She's going to tell us something about the singularity.
A black hole might be different than you imagine. It's a place and not a thing. The core of the star keeps collapsing, and where it goes, nobody knows. The black hole isn't anymore a crush of matter. It left it behind in its wake, but the stuff of the star is gone.
Okay, so she says that any matter that falls into the black hole does absolutely get crushed out of existence at the singularity. Nothing is left behind. So we have these contradictions between these people. Either you get stretched, either you stay on the surface of the event horizon, near the surface, or you fall into the singularity and you get crushed out of existence. Or I guess the fourth one is that you're stretched, and despite being stretched and all your bones get broken and all your muscles get pulled out of alignment, you are able to go through the singularity and end up in another universe, or early in the morning when you were drinking coffee. So you tell me which one of these scientists is correct. We have contradictions here, right? And but then Jana says not only that it's singularity is a place and not a thing. Then she corrects herself, and here I want you to hear her correct herself. See what she says. She says it's not a place, it's something else.
Once you pass the event horizon, space becomes time and time becomes space.
So from the outside, if you're an astronaut, you're watching your friend, another astronaut, going into the black hole, it's as though your times become rotated relative to each other. So the profound thing is, as an astronaut on the outside, looking at this round event horizon, you think of the center of black hole as a point in space. But to the person who's fallen in, it's not a point in space at all. It's a point in time. The singularity, or the end of it all, the crush in the center of the black hole, is in their future. So they can no more avoid the singularity than you can avoid the next instant of time coming. So the death in the singularity is inevitable. Although we don't really think the singularity necessarily exists.
Although we don't really think the singularity necessarily exists. Although we don't really think the singularity necessarily exists.
That singularity probably doesn't ever actually form.
That That singularity probably doesn't ever actually form. That singularity probably doesn't ever actually form.
So the singularity never forms. It's not a thing. It's a place, but actually not a place. It's a moment in time. What are we talking about here? I mean, we went from an object, a thing that's going to move stars around out there somewhere, and it's not a thing, it's a place. Now she says it's not really a place, it's a point in time. You tell me what we're talking about at this point. You know, I mean, they keep changing the goalposts here, you know, switching it, pushing it forward or backwards or whatever. And here we have another bozo, and boson. And his name is Derek Miller, and he's going to tell us the same thing, more or less, that it's a place, a moment in time.
Since the future always points up, it tells us that the singularity is not actually a place in space. Instead, it's a moment in time.
The singularity is a moment in time. The singularity is a moment in time. The singularity is a moment in time.
The very last moment in time for anything that enters a black hole.
Okay, so it's a moment in time according to these experts. Okay, yeah, some say it gets crushed out of existence. Others say the matter remains there. Now he says it's a moment in time. What are these people talking about? Why are they giving you physical interpretations if later on they're going to say, well, you know, we don't do that in physics, in mathematical physics. We don't give physical interpretations. Then why are they trying so hard to give you a physical interpretation? I mean, they should stick to math, right? I mean, you would think. And here he's going to confirm to us that, yeah, it's everything that's fallen in there stays at the surface, I guess, of the event horizon. In theory, you would see everything that has fallen into the black hole frozen on its horizon, including the star not forming. But in practice, photons are emitted at discrete intervals, so there will be a last photon emitted outside the horizon. He's only telling you what you can see, not what is real, what exists. And therefore, these images will fade after some time. And he said, this is the video about real science of black holes. Okay, so he's going to talk about he's going to give you a lecture, a real science lecture on black holes. And he says that all this stuff is suspended on the event horizon. It's timeless. It stays there forever. It doesn't get crushed out of existence, I guess. So, I don't know, you tell me. What conclusions can we reach from all this? Well, here's a summary. Okay, we have most math experts have calculated that singularity crushes all matter out of existence. Not one atom survives. But expert Janet Levin confirms that all matter is gone. There's no matter there. Okay. I guess she's in line with all these people. But then she changes her mind because she's going to give a different idea later on. He says it's all gone, but, you know, and here you have other mathematicians. They tell you that matter is stretched forever from the event horizon to the singularity. Okay, so now if it's gone, how come it's stretched? You know, what's being stretched and for how long? And it says stretched forever because, you know, the astronaut's feet, which went first through the event horizon, never reach the singularity because it's always in the future. The singularity is never in the present, it's always in the future, she says. Okay, so here these people have their feet close to the singularity but never touching it because it just goes, it's always in the future, in their future. What does Derek Miller says? He argues that objects never reach the singularity. There you go. And Jana says that a singularity is a place. Okay? Then she corrects herself and says, no, I'm sorry. She says it's actually a moment in time. So is it a place or a moment in time? And Derek Miller confirms that a singularity is not a place, but rather a moment in time. So the question, are these mathematicians kidding us? Are they experts? What are they doing? Are they just entertainers, clowns, giving these so-called scientific presentations? And then the question, the bottom line question, the ultimate question, why are they giving physical interpretations, right? Why are they giving you all these physical interpretations if mathematicians, mathematical physics, they're on record that stating that math physics is solely about equations, okay? So if they're going to do equations, why don't they stick to equations? Why? Why are they giving you a physical interpretations if they don't do physical interpretations? And the only physical interpretations they have are irrational. Why are they harping on it? Why are they including it in their dissertations? They should keep that out. Because they're giving you an irrational interpretation. They tell you to believe it. When you confront them, they say, well, we don't do that anyways. That's philosophy. So this is the status of so-called science today. And so you got to keep in mind the context here. How these people are handling the propaganda. They're commercial for mathematical physics. And that's what they do. They're just proselytizing stuff that ain't so.